Okay, we're going to review solving one-step equations. This is from last semester. Solve one-step equations. And instead of saying one step, instead of saying step, we could have just used the word operation because it's just one operation that's being done. So if you remember the goal to solving equations, the goal is to get the variable alone. And again, you can abbreviate as much as you like. To get the variable alone. Alone on one side. And how are we going to do that? How are we going to get the variable alone? We're going to use inverse operations. That's how we're going to solve these equations. Inverse operations. Remember, inverse, that just means opposite. Means the opposite. In operations is adding, subtracting, multiplying, and dividing. So we're going to do the opposite. So if it's adding, we're going to subtract. And if it's multiplying, we're going to divide. The other thing to keep in mind is that on equations, it's like having a balance. So what you do to one side, you have to do the other side. Or you could think of it as a teeter-totter. So if you add weight to one side, you have to add weight to the other. If you take away weight, you have to take away weight. So think of it in that terms. What you do to one side, you have to do to the other side. Okay, we'll do about 9 examples. So kind of keep that in mind as you're going through writing your notes. So number 1, we have x plus 6 equals 4. We want the letter by itself, the x. So remember, there's 2 sides. You have the left side, the right side. We want the x by itself. I have to get rid of this plus 6. I do its opposite. I subtract 6. I'll do that to both sides. What you do to one side, you must do the other. How come I didn't subtract 4? Because I want the x by itself. I want to get rid of the plus 6. This leaves me with only x. And these 6's disappear because 6 and minus 6 is 0. Bring down the equals. 4 take away 6. There's more negative. How much more negative is there? 2. The answer is negative 2. Now, if you wanted to check this, you take negative 2, plug it in there. Negative 2 plus 6 is 4. It works out. But since we're doing one step, we'll just check mentally. Number 3, 25 plus x equals 40. Now our goal is to get the letter by itself. You think of this as like a teeter-totter, a balance. So let's see, I need to get rid of what? The 40 or the 25? You need to get rid of the 25. Is that a positive 25 or a negative 25? That's the positive 25. So do its opposite. Opposite of positive 25 is negative 25. And I have to do that to both sides. Okay, I'll bring down my equals. On this side, 25 that makes 0. Bring down my x. 40 minus 25. Let's see, that would be 15. And you can check that out. Put 15 in it for x. 25 plus 15 is 40. Number 4, negative 12 equals x minus 20. Okay, let's see. So here's our balance. We want the x by itself, so we're going to have to get rid of the negative 20, minus 20. To do that, I do the opposite. I add 20. Then I have to add 20 over here. You have to do it to both sides. You have to be fair. I bring down my equals. Try and keep the equals lined up. Bring down the x. Negative 20 and plus 20 is 0. That's why we did that, to get the x by itself. Now it's by itself. And over here, that's 20 take away 12. 20 take away 12 is simply 8. Okay, and is that right? 20 take away 12? Yeah, that's 8. So let's see if that works out. If I put an 8 in there, 8 minus 20, does that equal negative 12? 8 take away 20? Yeah, that works out. So it doesn't matter if the x is on the left or the right side, that's fine. If you want to leave it on the right, leave it on the right. If you want to flip the whole problem around, go ahead and do that. I prefer just to leave it alone as it is. So I still have some room down below on my paper and some on the side. I'm probably going to make 2 columns here and then go down that way. I still have room down here, so I'm going to move there. And notice I wrote the problem twice. That's so that I can go back and see what I've done to the problem. So could you please do that also? Just write the problem twice. 5x equals negative 20. And then we'll do all our work on the second one. So I have 5x equals negative 20. Let's see. I want to get rid of what? The 5 or the negative 20? I want to get rid of the 5. Now this is 5 times x. The opposite of times is divide. So I will divide by 5, that same number. And I'll do that over on this side. Now, can you see when I do this? 5 divided by 5 is 1. This is like it kind of cancels each other out and leaves you with just the letter x. I'll bring my equals straight down. On this side, 5 goes into 24, and there's 1 negative. And I can check my answer. I can always just take negative 4 and plug it in there. 5 times negative 4. 5 times negative 4 is negative 20. It works out. That is the correct answer. Here's number 7. Again, I wrote the problem twice. So let's see, I have, to get the variable by itself, I need to get rid of the 4, the negative 4. Now that's negative 4 times x. There's a times in there. The opposite of times is divide. Right? That's the inverse. And so I will just divide by negative 4. What I do to the left, I have to do to the right. And that's going to leave me, let's see, I have an x. The 4's reduce, or they cancel, to 1. And then negative divided by negative is a positive. Two negatives cancel when multiplying or dividing. And then we have 28 divided by 4, that's 7, and there's one negative. And if you plug that in there, negative 4 times negative 7 is 28, positive 28. It works. I think we'll just stick with one more example, but before I do that, I need to show you a little something here first. Okay, let's say we have a problem like this, negative x over 4. Not a problem, just a fraction. Negative x divided by 4. That is the same thing as this, having a negative in the very center instead of having it up above. Which is the same thing as this, having the negative down below instead of in the middle or above. See, it doesn't matter. You just have one negative in there. It doesn't matter where it's at, the top, middle, or the bottom. And don't forget, there's always the invisible 1 in front of the x. So you really could have it like this, 1 over negative 4 times x. It's all the same. All of this is the same. You can look at it at different angles, but it's all the same. So we'll just go ahead and just kind of cloud that in and just kind of keep that in mind. So if you see something like this, you could change it to look like this or change it to look like this. Whatever's easier for you. You can just change it around. So here's our last example. So if it helps you, for the second one here, instead of having the negative on the top, you can just put it down below at the bottom. Okay, it's the same thing. And so this is divide by negative 4. The opposite of divide by negative 4 would be to multiply by negative 4. Okay, remember, this is up on top. So I have to do it to this side, multiply by negative 4. And these all cancel out. They reduce to 1, which leaves you just with x. That's what you want. You want the variable by itself, all alone. And then 7 times 4 is 28, and you have one negative. And does that work right? Does that work out? If I make negative 28, that works out, because that makes a positive 28 divided by 4 is 7. It works.